Chapter 1: Introduced to Forensic Chemistry. What is forensic chemistry? Forensic chemistry refers to the branch of chemistry that deals with the application of chemical theories and principles in the solution of legal problems in relation to the administration of justice. This field of study applies science and technology to investigate and establish facts in criminal or civil courts of law. In simple terms, forensic chemistry is the application of chemistry to law. The word forensic is derived from the Latin word forenses, which means of the forum, or speaking the truth in public. The forum, arguably the historical equivalent of modern day courts, is also a place where ancient Romans used to conduct public discussion. Therefore, forensic science is the application of scientific principles to criminal and civil laws, which are enforced by police agencies in a criminal justice system. The history of forensic chemistry can be traced back to the use of poisons by the ancient Egyptian, Greeks, and Romans. Democritus, an ancient philosopher widely considered as the father of modern science, was probably the first to study poisons. Poisoning was used by the ancient world as a method of murder and execution, as when Socrates was sentenced to death by drinking hemlock, a highly poisonous plant. The use of arsenic, a very poisonous metallic element, was widespread during this time. That by 82 BCE, the ancient Roman civilization created laws against poisoning in 7552. The first actual chemical test for poison was undertaken during the Blinded trial in 1836. The Mars test was developed, which was the first reliable analysis that scientifically demonstrated the presence of arsenic in the body of a victim. Centuries later, Belgian chemist Jean Serbius Stas, 1813 to 1891, conducted studies on various methods employed to detect certain types of vegetable poisons in the body. Stas is best known for his work in determining the automatic weight of the elements and served as the leading chemist in Belgium during his time. In 1851, Stas was required to examine the organs of a dead body involved in a notorious murder case, concluding that the victim has been poisoned by nicotine, a natural product considered to have been responsible for unsolved murders at that time. The mid-19th century saw the rapid advancement of forensic chemistry. Tests for blood were developed through the efforts of German-Swiss chemist Christian Friedrich Schonben, who discovered the first reliable method for identifying human blood in 1863, and Dutch chemist Isaac van Dien, who developed another test for the presence of blood at about the same time in 1832. British chemist James Mars invented the Mars test for arsenic. It was also during this period when studies on bullet fingerprinting began, enabling the identification of weapons used in crimes and the individuals who used them. By the following century, for studies ushered in the development of sophisticated methods for the fingerprinting of bullets. Locard's exchange principle. Another key figure in the history of forensic science is Edmond Locard, 1877 to 1966, who also made several significant contributions to the new science of fingerprinting. Locard succeeded in setting up the first police laboratory in Lyon, France in 1910. He is best known for the Locard exchange principle, which has been adopted as one of the tenets of forensic science. The principle holds that every contact leaves a trace, or that every contact between two objects result in an exchange of traces between them. In other words, it is impossible for a criminal to perform an act of violent crime without having some trace of his or her present. As an example, Locard highlighted the power of the microscope to characterize the debris deposited on the clothing of a person moving through different environments. This principle is further explained below. Wherever step, whatever it touches, whatever lives in unconsciously will serve as a silent witness against him. Not only his fingerprints or his footprints, but his hair, the fibers from his clothes, the glass he breaks, the tool mark he leaves, the paint he scratches, the blood or semen he deposits or collects. All of this and more bear mute witness against him. This is evidence that those not forget is not confused by the excitement of the moment. It is not absent because human witnesses are. It is a factual evidence. Physical evidence cannot be wrong. It cannot perjure itself. It cannot be wholly absent. Only human failure to find it, study, and understand it can diminish its value. Ofela, father of modern forensic toxicology. Mateo Joseph Bonaventure Orfela, 787 to 1853, a Spaniard who worked at the University of Paris in the early 19th century, is regarded as the father of modern toxicology. He pursued a career in medicine, was appointed professor of medical jurisprudence, and was a professor of chemistry in the School of Medicine before serving as the dean of the faculty at the University of Paris. Orfela established numerous basic principles of modern toxicology. It is probably the first person to conduct experiments of the effect of poison in 1813. He wrote the first book devoted exclusively to toxicology, Treat This Poison, Treatise on Poison. He published other books in medical chemistry, Element of Medicinal Chemistry, 1830, Exhumed Bodies, Treatise on Legal Exhumations, 1830, and that Toxic Effect of Arsenic, Research on Poisoning by Arsenious Acid, 1841. Orfela was also frequently summoned in criminal trials as an expert witness on the use of poison. Sir Francis Galton, fingerprints. The role of fingerprinting in the field of forensic science was established with the publication of the first scientific book on fingerprinting in 1892. This landmark work was entitled Fingerprints and was written by Sir Francis Galton 1822 to 1911. Using previous studies, Galton developed a system wherein a precise pattern of a set of prints could be used to identify its owner. Galton's Sims uses a categorization based on three main pattern types of loops, whorls, and arches. A person's fingerprint identity consists of a sequence of these patterns. Originally, the system was developed for Galton's studies on racial characteristic and heredity and not for crime detection application. However, within a decade, law enforcement officers and criminal prosecutors have begun to use Galton's book to accurately identify and convict criminals. Importance of forensic chemistry. Forensic science deals with the application of science to legal matters in crime solving. Chemistry plays an essential role in the interdisciplinary field of forensic science, especially in the crime laboratory wherein the same principles and laws of chemistry are used to examine evidence. Crime scenes analysis involve the use of forensic chemistry principles in establishing the causes of unnatural death, detecting illegal drugs in blood and urine, and determining the causes of fire. Therefore, methods of research, practice, and presentation must meet the needs of both the scientific and legal communities. At present, forensic chemistry has proven to be very effective in reconstructing sequence of events that constitute the crime being investigated, thus bringing a perpetrator close to the crime he or she has committed. Such accurate information may eventually lead to the perpetration, identification, arrest, and conviction. Forensic laboratories in the Philippines. In the Philippines, the practice of forensic began with the passage of the Royal Decree number 188 by King Philip during the Spanish rule in the country. Under this decree, forensic physicians called medicus titularis were assigned to the Philippine province to perform public, sanitary, and medico-legal duties. Today, there are several forensic laboratories in the country, including those from the 5 district office to satellite crime laboratories in Valenzuela City and Marikina City, regional and provincial office of the Philippines National Police, PNP, the University of the Philippines, General Hospital, UP-PGH, and Manila, the Philippine Drug Enforcement Agency, PDEA, and Quezon City, and the National Bureau of Investigation, NBI, and Manila and its regional and provincial offices. The Crime Laboratory. A crime laboratory, or crime lab for short, is a scientific laboratory that uses forensic science for the purpose of examining evidence from criminal cases. It refers to the laboratory where highly trained technical personnel render various related services. The PNP Crime Laboratory consists of uniformed and non-uniformed personnel which high level of expertise and the ability to provide scientific investigation services, truth, fieldwork, crime science operation, forensic laboratory service, as well as criminalistics training and research. Allied service include autopsy, drug test, DNA examination, examination of questioned documents, fingerprinting service, histopathological examination, macro itching examination, semen determination, and so on. Requesting parties must submit an official letter of request for the specific service together with the evidence or specimen and other details about the specimen, suspect, the time and date of confiscation, the nature of the case, and the type of examination requested in drug specimen. A chain of custody form must be completed and signed by all persons who handled the subject drug specimen. Below is the table showing the jurisdiction or physical evidence according to the examination to be performed. Physical nature evidence, fingerprints, firearms evidence, biological evidence, trace evidence, document evidence, physical matching evidence, toxicology evidence, drug evidence, macro etching for vehicles. Branch of Examiner PNP Crime Lab, Fingerprint Division, Firearm Identification Division, Biological Evidence, Physical Identification Division, Question Document Division, Physical Matching Evidence, Chemistry Division, Chemistry Division, Physical Identification Division. The forensic chemist. A forensic chemist is a professional chemist who analyzes evidence from the crime scenes and derives a conclusion based on tests undertaken on such evidence. It is the task of the forensic chemist to identify and characterize the evidence as part of the overall crime solving process. Given that they handle the evidence collected from the crime scene, they are often summoned to explain in a trial court what was found and how they arrived at their conclusion. They can provide technical explanation that can assist in a final judgment as well as analyze the evidence. However, they cannot determine the verdict, versatility, and patience are the cited qualities of a forensic chemist. Characteristic of a forensic chemist. The practice of forensic chemistry in the Philippines, similar to other chemistry practices, is covered by Republic Act Number 754, also known as the Chemistry Law. This was enacted on June 18, 1952. The Chemistry Law clearly states that a registered chemist is any person who is engaged in the professional practice of chemistry and is duly registered with the Board of Chemistry and the Professional Regulation Commission to undertake the professional practice of chemistry, among others. A forensic chemist must, number one, be able to spend hours rigorously applying an analytical technique to evidence. Number two, clearly and concisely answers challenge to his findings. And number three, possess moral integrity.